Okay, going to look at horizontal asymptotes. Horizontal asymptotes describe what we call end behavior of a function. Okay, this is what happens on the outside edges of the function. Okay, this is really important that you understand horizontal asymptotes are different than vertical asymptotes in that. They can be found by determining whether the numerator or the denominator, okay, of the function eventually grows the quickest, or if they eventually grow at the same rate. To find horizontal asymptotes, you can think of putting very large numbers, okay, into the function. Alright, so just before we get to the rules, the general rules, let's just take a look at this. For example, if I have f of x equals 1 over x plus 2, what I have below here are charts that correspond to these functions. And you'll notice, as I put in large numbers that get closer to negative infinity, my function in this case is getting closer to 0. That's because the bottom here is growing much bigger, okay, growing faster. Oops. Growing fast. Okay. And the numerator is not growing at all. So you're taking 1 and dividing it by a very large number, and it takes it to 0. Similarly here, as we go towards infinity, we're plugging really big numbers in here, like 1 over 10,002. That makes the ratio close to 0. So you'll notice here, if the bottom grows quicker, then the ratio approaches 0 towards the outside parts of the graph. Same with g of x. Let's take a look at g of x here. If we start putting large numbers in here, really what ends up happening is this x and this x here really kind of dominate this this rational expression on the outside edges, and eventually this 3 pretty much goes away. So you really just have a ratio of 2 over 1, and you'll notice here that as I put in very large negative numbers, as I get closer to negative infinity, the ratio of the top to the bottom gets closer to 2. Same if I put really big numbers in, that 3 becomes insignificant, and as I get closer to infinity, this number is approaching 2. Lastly, on the last one, here we have an x, but here we have an x squared. And when you put very large numbers in, the x squared starts to dominate this ratio, meaning that the bottom is growing faster, okay, than the top. And when that happens, the ratio will eventually, when you put really large numbers in, the ratio will approach 0. You can see it happening there in those charts. Okay, so for general rules for finding horizontal asymptotes, if you're given this rational function here, if the degree of p of x is less than the degree of d of x. In other words, you know, I like to think of it as d of x is bottom heavy. There's a horizontal asymptote at y equals 0. That's like in the first example and the last example that we saw there. If the degree of p of x, which is the numerator polynomial, is equal to the degree of d of x, okay, that's the polynomial in the denominator, there's a horizontal asymptote at the leading coefficient of p of x divided by the leading coefficient, alright, of d of x. Now that is like the middle one that we saw up here where it went to 2. Notice the leading coefficient was 2 in the top, and in the bottom it was 1, so it was 2 over 1. Alright, and that's why it approached 2 up here. Last, if the degree of p of x is more than the degree of d of x, then there is no horizontal asymptote. So if the top grows faster than the bottom, there's no horizontal asymptote. Let's take a look at that real quick. Using the general rules, determine the functions have horizontal asymptotes. Well, if we look here, our degree is 2 in the numerator and 1 in the denominator. So the top is growing faster, which is going to make it grow without bounds, so there is no horizontal asymptote in this case, by rule number 3, if you want to check that. Alright? Now, in this case, the second one, They're both squared. That's the highest power of x. And in this case, neither one will dominate, and these other ones will essentially go away, these other terms. So really what you end up with is something that's approximately way out when you're putting in big numbers to essentially 2/3. Okay? And that's our leading coefficient over our leading coefficient. So y equals 2/3 is your horizontal asymptote in that case.